Hello, it's Medicosis Perfectionalis, where medicine makes perfect sense. Medicine and chemistry, that is. Welcome back to my chemistry quick review playlist. In previous videos, we talked about elements, compounds, periodic table, and the periodic trends. We also talked about how to draw a Lewis dot structure, as well as the electron configuration of the elements. As for today, we shall discuss the different types of bonds, such as ionic bonds, covalent bonds, and metallic bonds, between metal and nonmetal, between two nonmetals, and between metals. I'll also show you how to write down a chemical equation. Reactants on the left side, products on the right side, and this arrow means yield. Let's get started. Please watch the videos in this chemistry quick review playlist in order. First, let's answer the question of the previous video. Suppose that an unknown element, let's call it X, has the following electron configuration: 1s2, 2s2, 2p6, 3s2, 3p6. The question is, what element is it? Please pause and try to answer this yourself. Let's do it together. It's very easy. You simply have to add all of these electron numbers together. Let's sum them up. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18. Now look at your periodic table. What is the element that has 18 electrons? Answer: argon. It's the element whose atomic number is 18. And as you know, the atomic number is the number of protons, which happen to equal the number of electrons in the neutral atom. Let's review what we have discussed before. The matter could be pure or a mixture. The pure matter is element or compound. Elements exist as molecules. Molecules are made of atoms. The atom has a nucleus centrally and electrons peripherally. The electrons are organized in orbits or shells, followed by suborbits or subshells, and each subshell has orbitals. Each orbital has 2 electrons maximum. Just like you write English, you need letters and then you combine them together to make words. You combine them together to make complete sentences. Similarly, we start with elements, lump them together, combine them together in chemical reactions to give me compounds. And how do you write the complete sentence? The balanced chemical equation. Reactants on the left side and products on the right side. The arrow means yield. The chemical equation ought to be balanced, which means I have 2 sodium atoms here and 2 sodium atoms here. Bingo, balance. How about chlorine? 2 chlorine atoms here and 2 chlorine atoms here. This is a balanced chemical equation. And then you can also write the state of the matter. So when you see S like this, it means it's a solid element. When you see this, it means liquid, such as water. When you see this, it means aqueous, which means soluble in water. And when you see G, it means a gas. Remember the valence electrons? Oh yeah, these are the electrons not in any shell, but only in the outermost shell of the atom. These valence electrons in the outer shell are divided into bonding pair. They form bonds like this. And I've told you before, when you see a single bond like this, it means there are 2 electrons hidden inside the bond and shared between these 2 elements. So now hydrogen is enjoying 2 electrons and chlorine is basking in the glory of 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. Hydrogen is happy with the duplet and chlorine is satisfied with the octet, meaning 8 electrons. How about the electrons that are not part of the bond? What do you call them? Lone pairs. Here is a lone pair, another lone pair, a third lone pair. How about an ion? Well, when a neutral atom loses a negative electron, when you lose a negative, you become positive. Positive ion is known as a cation, such as what happened to the sodium atom. When it lost 1 electron, it became sodium positive 1 ion. How about the chlorine? When the chlorine gained a negative electron, it became a negative ion, i.e. anion. And since it just gained 1 electron, we'll call it chlorine negative 1. But let's say that the neutral oxygen atom gained 2 electrons. Oh, electrons are negative, so we will write the ion like this. Now please be careful with the nomenclature. This is chlorine atom. This is chlorine molecule. But this is chloride ion. Similarly, this is oxygen atom. This is oxygen molecule or molecular oxygen. And this is called an oxide. Chlorine versus chloride. Oxygen versus oxide. Some of these ions are monoatomic. For example, sodium like this. Oh, look at that. Oh, it is just one atom of sodium. How about this? One atom of chlorine. Or it could be polyatomic ion. Here's the sulfur atom and different type. Not sulfur this time, but oxygen. Oh, I have different types of atoms. Polyatomic ion. And this negative charge or double negative charge does not belong to the oxygen alone. It does not belong to the sulfur alone. It belongs to the entire polyatomic ion. Recall that metals tend to be on the left side of the periodic table and they tend to lose electrons to achieve the octet. Conversely, nonmetals tend to be on the right side of the periodic table and they tend to gain electrons to achieve the octet. If you lose electrons, you become a positive ion, but if you gain electrons, you become a negative ion. Let's talk about different types of bonds. We have ionic bonds, covalent bonds, and metallic bonds. Ionic bonds form between a metal and a nonmetal. How about covalent bonds or molecular bonds between nonmetal and nonmetal? How about metallic bonds between metal atoms? Metal and metal. Okie dokie. Ionic bonds is all about give and take. One atom is losing an electron, the other atom is gaining an electron, such as sodium chloride. Sodium is losing an electron and becoming a positive ion in the process, while chlorine is gaining an electron and becoming a negative ion in the process. That's an ionic bond, and sodium chloride is an ionic compound. How about covalent? Is it about giving and taking? No, it's about sharing electrons together. We can share one pair of electrons and make a single bond. This chlorine atom is sharing one, and this chlorine atom is sharing one. 1 plus 1 is 2, and they share these 2 electrons in the single bond together, so that each atom achieves the octet rule and becomes fully satisfied with 8 electrons in the valence shell. How about if we shared 2 electron pairs? We'll form double covalent bond instead of a single covalent bond. How about 3 pairs of electrons? Triple covalent bond. Example of a double covalent bond is between the oxygen atom and the oxygen atom in the O2 oxygen molecule. If you want a triple covalent bond, it's the classic example of nitrogen in the N2 molecule. How about metallic? Oh, metallic, it's not sharing, it is more than sharing. These metal atoms agreed to delocalize their valence electrons, so that you cannot say that this electron belongs to this atom or this atom anymore. They have formed a commune of electrons. So ionic bonds, giving and taking, is the capitalist. Covalent is the socialist, sharing. And metallic is the communist. By the way, these metallic bonds are what give metals their characteristic properties like strength, luster, electric conductivity, and thermal conductivity. Of course, metals are good conductors of electricity and heat. Note that sodium chloride is polar. What does the word polar mean? It means it has poles, a positive pole and a negative pole. I can cut the compound with a knife here and I will find different charges, a positive to this side and a negative to this side, i.e. it has poles, therefore polar, therefore water-soluble. How about the covalent compounds? Well, I made a mistake here. The Cl2 is non-polar, while the HCl is polar. Let me explain. Cl2, why are you non-polar? Because if I cut this compound with a knife right here, I have Cl here and Cl here. They are exactly identical, which means I cannot say that I have different poles. The two sides are exactly identical. There is no tilt, i.e. there is no poles, and the compound is non-polar and not water-soluble. Conversely, look at the HCl. Who is more electronegative? Electronegative? What is electronegative? Please watch my video titled Periodic Trends. Electronegativity is the ability to attract electrons. We know that the electronegativity of chlorine is greater than the electronegativity of hydrogen, and therefore chlorine will attract electrons more towards it as compared to hydrogen. So the electrons are more towards chlorine, which means chlorine will acquire a partial negative charge, while hydrogen will be the partial positive, because as you know, electrons are negative. If electrons are attracted more towards you, you will have a partial negative charge. So if I cut this compound with a knife right here, do I see a difference? Of course, partial negative here and partial positive here. These two atoms have different electronegativity, so of course there is tilt. We have poles, partial positive and partial negative, and this is a water-soluble compound. So if you are a covalent or a molecular compound, you could be polar or non-polar. Here is electronegativity, which we have discussed before in my video on periodic trends. It's the ability to attract electrons. Usually smaller atoms tend to be more electronegative, and what's the most electronegative atom? Fluorine. So if you're getting closer to fluorine, i.e. if you're going to the right side of the periodic table, and if you're going up a group until you reach fluorine, electronegativity tends to increase. But if you're going away from fluorine, i.e. rightwards and downwards, therefore the electronegativity will decrease. Here is electronegativity. What's the most electronegative atom? Fluorine. So if I'm going this way, away from fluorine, electronegativity decreases. But if I'm going this way towards fluorine, then my electronegativity tends to increase. And this electronegativity is so important because the difference in electronegativity between different atoms will determine the type of the bond. If the difference in electronegativity is between 0 and 0.4, we have a nonpolar covalent compound, such as chlorine molecule. If the difference in electronegativity is between 0.4 and 1.7, then we have a polar covalent compound, such as HCl, hydrogen chloride. But if the difference in electronegativity is 1.7 or greater, then we have an ionic bond and an ionic compound. But hey, Medicosis, what if the difference in electronegativity is precisely 0.4? Well, ask your professor or teacher. I would like to consider it with the higher stuff. So 0.4 belongs to polar covalent. And if it's exactly 1.7, then I consider it ionic. Compounds could be ionic compounds or covalent or molecular compounds. Based on what? Based on the type of the bond. Ionic compounds, like sodium chloride, have ionic bonds. Yes, indeed. And covalent compounds have covalent bonds, as in hydrogen chloride. Why is sodium chloride ionic but hydrogen chloride covalent? Easy. Measure the difference in electronegativity between sodium and chloride. You will find it greater than 1.7, therefore ionic. Then measure the difference in electronegativity between hydrogen and chloride. You will find the difference is less than 1.7, therefore covalent. Next, what is a binary compound? The word bi means two, so it's a compound made of two different types of elements. Sometimes these two elements are metal and non-metal, or it's possible that the two different elements are two different non-metals, like hydrogen, a non-metal, and chlorine, a non-metal. Let's go to metal and non-metal. Well, it depends on the type of the metal. Is it one of the alkali or alkaline earth metals, i.e. group 1a and group 2a respectively? If so, then we can only form one type of positive ions. Example, sodium is in group 1 or group 1a, therefore sodium can only form one type of cations, and this is sodium 1+. That's it. Sodium cannot give you any other cation. How about lithium, also group 1a, Li+1. That's the only possibility for a cation of lithium. How about magnesium? It's in group 2a, so only Mg2+, and no other possibilities. I give you only one type of cations, and one example here is sodium chloride. Sodium is a metal, chlorine is a non-metal. However, if this metal is a transitional metals in the middle of the periodic table, then in many cases I can give you two or more different types of cations. For example, copper can give you copper 1+ or copper 2+. Iron can give you iron 2+ and iron 3+. And these were what? Binary compounds. Why binary? Two different types of elements. Here is an element, here is another type of element. Here is iron, here is chlorine. Together they are iron chloride. You replace the "-ine" of chlorine with "-ide", as in chloride. And to differentiate between iron 2 and iron 3, you write Roman numerals. So this is iron, Roman numeral 3, chloride. How about an ionic compound made of 3 or more different types of elements? What do you call that? Ternary ionic compound. Ternary or tertiary trio, 3. And these 3 different types of elements could be polyatomic ion. Here's an element called barium, here's an element called sulfur, and here's an element called oxygen. So we have a metal called barium and a polyatomic ion. And when we have a polyatomic ion, we will not say barium sulfide, we will say barium sulfate, i.e. sulfate group will retain its name. It will retain the suffix ate. What is a polyatomic ion? The name has the answer. It's an ion, i.e. it carries a charge, whether positive or negative. And polyatomic. Poly means many, atom is an atom. So it's an ion made of multiple atoms. And these atoms are covalently bonded. Example, hypochlorite. Oh, look at this, ClO-. The negative charge does not belong to oxygen alone. It does not belong to chlorine. It belongs to all of them. The entire polyatomic ion is negative. How about ammonium? Oh, it's a polyatomic ion with a positive charge. And again, the positive charge belongs to the entire thing. Important ions to memorize. These ions are positive 1, and these are positive 2, positive 3, and positive 4. How about here? Negative 1, negative 2, negative 3. Note that gold could be +1 or +3. How about copper? Could be +1 or +2. And that's why we need Roman numerals. Chromium, there is chromium 2, 2+, and chromium 3, 3+. Cobalt, 2+ and 3+. These are transition metals, and that's why they give us positive charges. How about iron? There is iron 2 and iron 3. There is lead 2 and lead 4.
Hey Medicosis, if I'm writing with a pencil and part of the lead got into my mouth, do you think I'll suffer from lead poisoning?
Shut up. The lead in your pencil is not lead. It's graphite, good old carbon. Not PB. It's not real lead, which means it's impossible to get lead poisoning from a pencil. It's just a misnomer. We call them lead pencil, but they do not have lead. Be very careful with the negative ions, especially the negative polyatomic ions. NO3-1 is nitrate. NO2-1 is nitrite. Nitrate versus nitrite. Similarly, chlorate versus chlorite. Sulfate versus sulfite versus sulfide. Sulfate is SO4 2 negative. Sulfite SO3 2 negative. Sulfide is just the sulfur 2 negative, as in oxide. If it's a polyatomic ion, it has 8 or 8. But if it's just one atom that has gained electrons, then we call it an ide, as in sulfide, oxide, chloride, iodide, bromide, fluoride, phosphide, nitride, etc. You have to memorize all of these. So if you want to be a good student, bring a piece of paper and draw all of this from scratch. Bonus points if you can write all of these down without looking. Transition metals, they have options. Copper could be copper 1+ or 2+. Gold 1+ or 3+. Iron 2+ or 3+. Ferrous or ferric. How about cobalt 2+ or 3+. Chromium 2+ or 3+. Vanadium 2+ or 3+. Manganese 1+ or 4+. Lead 2+ or 4+. Titanium 2+ or 4+. Pay attention, the abbreviation of tin is SN, not TI. TI is titanium, SN is tin. Quiz time! If the electronegativity of lithium is 1 and the electronegativity of fluorine is 4, what's the type of the bond that forms between them in the compound lithium fluoride? Is it metallic, ionic, polar covalent, or non-polar covalent? Here is another question. If the electronegativity of hydrogen is here and of oxygen is here, what kind of bond or what kind of compound is water? Metallic, ionic, polar covalent, or non-polar covalent? Let me know your answer to these two questions in the comments, and you will find the answer key in the next video, where I'll teach you how to write ionic chemical formulas and how to name binary molecular compounds. If you find my videos helpful, please consider buying me a coffee at buymeacoffee.com/medicosis. There are more than 1,500 free educational videos on my channel, plus 300 premium videos that you can access right now if you click the join button and choose the highest tier. Smash like, subscribe, hit the bell, support my channel here or here, go to my website to download my notes, courses, and cases, or if you'd like me to personally tutor you. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine and chemistry make perfect sense.